Interfaces are a very powerful tool you can use in Unreal Engine when you need to interface between actors and don't need to specifically know too much about the other actor. The general idea behind an interface is to share functionality between different classes that aren't too similar to each other, such as objects that can be set on fire. Just because you could set wood and grass on fire doesn't mean you should treat your grass actor like a tree. We'll look at two examples, one for a Blueprint interface and one for a C++ created interface. For the first example, we're displaying a basic understanding of Blueprint interfaces by allowing different objects to be burnt in specific types of fire. There are three actors that the user can place in either the red flame or the blue flame. They react as follows. The wood is red fire only, the stone blue fire only, and the chair is both red and blue fire. The way the system works is via the two interfaces created, BPI Flammable Red and BPI Flammable Blue. These BPIs have identical functions inside, a simple function with no variable inputs, named Flame on Red and Flame on Blue respectively, but they are distinctly separate interfaces. The main reason these are separate interfaces are to show off one of the key features of an interface, giving the ability for an object to communicate with one of three items without having to know specifically which actor it is, or anything outside of I can do this thing that you want me to. If we take a look at either BP Wood or BP Stone, we can see that it simply has an incoming event from the Blueprint interface and a function to activate the attached particle system. If we take a peek into BP Chair, we can see that it has both interfaces, therefore we can tell it to do specific things based on which interface has been triggered. To check, add or remove an attached interface on a blueprint, you can head over to the class settings/interfaces to view or alter the implemented interfaces. Both fire blueprints use the same class. They switch functionality on the exposed ball, B is blue fire, so to see what's going on, we can open either of them. When an actor overlaps with BP fire, we check to see if this fire is supposed to be a blue fire or a red fire. Depending on the choice, we check to see if the actor overlapping has the interface to burn, blue interface for blue fire, etc. If the actor does, we fire the event to let them know that they have touched the fire. It's important to note that BP fire has zero knowledge of the wood, chair or stone. Even if we added another class, it still has zero knowledge of that class too. This is because all it cares about is, whoever this is, can they run this function? If so, tell them to do so. Before we move on to the C++ example, it's important to mention that an alternative implementation you could have done in this situation is use a shared base class, where wood, chair and stone share a common base class with a required function inside. But as you've seen, adding an interface allows us to add this kind of functionality to any actor, mixing and matching different interfaces without having to have unused code in your classes that might not be fully utilized. Within example 2, we are showcasing interfaces with a simple interact system. The basic flow is that when a player gets close to either of the two objects in the scene, BP chest or BP interact text, the player is notified that they can interact. When the player presses the interact button, we check with the stored actor and send off our interaction request. First, let's look at the .h file, KFI interact. It's important to note that for this interface, there's no accompanying CPP file, as we have used the Blueprint native event flag to enable us to call these functions from both Blueprint and C++. There are two classes here. One is a U interface, UKFI interact, and one is named IKFI interact. The idea here is that the U interface deals with the internal logic and does not need to be changed, and the IKFI interact deals with what you've come to expect from your classes, the outward facing function. There are three functions here ready to be implemented by those who inherit this interface. You can see how these are implemented by looking at KFI interact text.h. Just under the U class, the interface gets added at the end, just after the A actor. Near the bottom, we can see the implemented function for interact request on the line virtual void interact request implementation override. The implementation part is due to the fact we made our originating function a Blueprint native event. In KF interact text.cpp, we have an example of using the interface in C++ to communicate to a blueprint. Specifically, in the overlap started and overlap ended functions, you can see that we check if the other actor implements the interface we need, and if they do, tell them to fire their versions of the function and perform the visual feedback on our end afterwards. To see a blueprint version of dealing with the C++ created interface, we can check BP chest. Within BP chest, when our sphere has been overlapped, or that overlap has ended, we trigger the C++ created interface functions for entering and leaving the interaction zone. You can see what this code triggers by checking BP first person example 2. When entered interaction zone has been triggered, you can see that we are storing the actor and creating the interaction widget. If we peek at when left interaction zone is fired off, we check to see if it's our stored actor calling the function. If so, remove the interact widget and clear the interactable actor variable. Taking a look at the input action interact function, which is used when the player presses the interact button, we can see that if the interactable actor is valid from the enter interaction zone, then tell the actor to fire off their interact request interface function. Jumping back to BB Chest, we can see that the interact request implementation says that if closed, open us, and if open, close us. If you'd like to see how to create your own Blueprint interface or C++ interface, feel free to check the link in the description where we go more in detail about interfaces and interface examples at kitatus.github.io.